Hello everyone and welcome back to the YouTube channel, An American Professor. In this video, we're going to be continuing with the TAXII Reinforcement Learning Environment series. Now that you understand more about the GEM library and interacting with the TAXII library, for example, I'll continue explaining it. The TAXII environment is a classic reinforcement learning task where an agent needs to navigate a small grid world in order to pick up and drop off passengers at different locations. It is a simple environment that is often used to demonstrate the effectiveness of various reinforcement learning algorithms. So the TAXII will always start up here in this top left corner. And for the example I displayed in the last video, you can see it was a 5x5 grid where the agent, a TAXII, is able to move in 4 cardinal directions. These are the actions. Remember, I was doing environment.sample to sample the actions. Those are up, down, left, or right. And there are 4 designated locations in the grid, which are labeled as R, G, Y, and B. In each state is represented by the following tuple: taxi row, taxi column, and passenger location and destination. Note that the passenger location can also be in the TAXII, so that adds an extra 1 to the possible values that state component can take on. Furthermore, there are also 6 actions corresponding to the 4 I mentioned earlier, and also the pickup passenger or drop off passenger. The agent begins each episode at a randomly chosen location on the grid, and there is a passenger at one of the 4 locations. The goal of the agent is to navigate to the passenger's location, pick up the passenger, and then navigate to the passenger's desired destination and drop them off. The agent receives a reward of 20 plus 20 points for successfully completing this task. There are also a number of additional rules and features in the environment. The agent is able to pick up and drop off the passenger at any one of the 4 locations. The agent receives a reward of -1 point for each action taken until the objective is achieved of dropping the passenger off at the right destination. If the agent attempts to execute an illegal action, such as trying to drop off a passenger before picking one up, it receives a penalty of -10. Additionally, the environment includes a wall that blocks the agent's movement in certain locations. The agent is not able to move through the wall. And just going through the code again for setting up the TAXII environment, you import GEM, you make the environment, you reset the initial condition, you create a decision loop for a number of steps for the agent, and each time step or stage or time step, you're rendering the environment, you sample a random action, and you take a step in the environment. And 4 things are returned here from this environment.step function: the observation, so the next state that's seen, the reward for the previous time step, the done variable, which tells you if the episode is over or not, and this optional info parameter that's really never used. And lastly, I check if the episode is over, and you can print additional information down here, such as rewards, or you can save information later. This can be modified. This is just basic setup for interacting with the TAXII environment. So now that we understand the TAXII environment, in the next episode, we can train an RL agent to solve this task and start visualizing and or validating the learned behavior to show that it is optimal, or at least an intelligent policy has been learned. And to do that, we'll use tabular Q-learning for this TAXII environment in the next video. Until then, see you later.